if it's somehow going to cause a problem, it's going to crash the program. It catches it, and it does something else. It prompts you, it says to you, well, you can't really divide by 0 here. Let's carry on. So that's basically the 4 building blocks. Is that easy to follow, or is everyone's okay? Cool. Okay. Now I'm keeping this session very conceptual. I mean, just basically talking about concepts. I'm not going really deep into one language, but these 4 building blocks are common across all languages that I've coded in anyway, even Java. Yes, Java. Right. The next thing we're going to talk about is object-oriented programming. Who wants to cover that? Yeah. Good. So we'll talk about object-oriented programming. What's the difference between objects and non-objects? Any ideas? Other than these 4? Just objects. Object concept. That's all it is. No catch. Who knows what an interpreter and a compiler is? Who wants to give me a bit?
They're for interpreting what you write down into a language that the actual computer can process.
Okay.
Bring it down. So an interpreter converts a line of code one at a time, and a compiler takes it all at once and builds it down into machine code or whatever, or ever down into a lower level so it can be processed.
Alright, it's a good explanation, very easy. In non-object programming, linear programming, if you want to call it that, or object programming, they've got both types. They've got interpreter language and you've got compiler language as well. So you've got both. Like what's your name? Paul. Like Paul said, you know, interpreter takes one line by line. So if you had 100 lines and line 99 had an error in it, you had a missing semicolon, it would actually run until line 99, it would stop. But in compiler, it would crash. It would say to you, look, there's an error, you need to sort this error before you proceed any further. Before we can compile the code, you need to sort this error, you need to put that semicolon in or something. In object-oriented programming, which is the C++, C was non-objects, and then C++ came along. And Java, pure object-oriented programming language, purely on objects. There's 4 different concepts, or there's 5 concepts here. First one, encapsulation, which I'm going to explain in a moment. This is the basics of object-oriented programming. What they've done is they said, right, okay, everything in the world is an object. I'm an object, this chair is an object, this table is an object, and anything related to it, we're going to put it into one block. So, for example, let's say the example of an employee. I'm going to give you the example of an employee. The way you start is you say class. You would put class and then you say employee here. And everything related to an employee, you would put it in a block of code here. Now in Java and in other languages, what they do, they give you a privilege. So they say public. So public basically means this object is accessible anywhere in a program. So you can actually use this object. It's not going to be a private object that's going to be exclusive somewhere. So this is going to be accessed later on in the program, in the main program. And then so anything related to an employee, we put it here. So all the variables that we said, like I, for example, in this case, we're going to say employee number. Right, so employee number is going to be an integer value. And then we've got semicolon at the end. What else do we have? We have string, so we could say employee name. So what we're going to, these are the 2 variables that it has. And when you perform something, it's called a function. Like this pen has some features. I mean, it's got a brand on it, it's got W.H. Smith's on it, it's got a length. These things, these are called properties. These are the properties of the pen. And then what's the function of the pen it writes? So if I was creating an object called pen, I would say the function write. So the function of this class, this employee class, is it works out the salary. Every single employee that we have in the company gets paid a salary, earns something at the end of the month or the week. So what we're going to do is we're going to create a method or a function that would work out the salary that that employee would earn. So what in here I'm going to do is I'm going to say public, let's say for example it does it in double, double is basically like a float number. So when you're talking about numbers, you do it double or float, decimal.
Sam, before we do the public double, do we have to close the class above, or does that stay open?
No, that's still open.
That's still open.
It's open because it's one block. So all the properties and all the methods, all the functions of that object is in one block. That's the first thing that's called encapsulation, when you encapsulate everything into one object. So you say public double get salary, and then what you do, you put all the arguments, anything that function is going to take. So it's going to work out. It's going to take two things. It's going to take hours and how much you earn per hour. So we need to put that in here, basically, in these brackets. So the first thing we're going to say is the hours, number of hours. Int hour, h, and we put a comma, and then we're going to say double rate. So that's double. Yeah. So basically the rate, how much you earn, you could earn £5.99 an hour, £12.50 an hour, £25 an hour, 25p. So it's like basically a float number. Yeah? So it could be like that, £1.50 if you're very poor like me. Hi, come in. Hi, welcome. So basically you would take this argument. This is also called the signature of the method. And then what we're going to do, we're going to start working out the formula. Now it's very simple. What we're going to do, we're going to multiply the number of hours by the rate. So we say here return hour times rate. And what that's going to do is it's going to multiply the hours times rate and return the value into here. Now, if we didn't want to return the value, we didn't want to retain the value anywhere to be used later on, what we do, we actually put something called void. Void basically means that we're not going to retain any value. In this case, we can't use the return. We'll just say print. We can use a print statement, or printf in Java, or echo in PHP, and then we'll just say print this. So multiply this together and just give us the value on the screen. Every time we do a statement, just always remember to put a semicolon at the end. Okay? But in this case, what we want to do, we just want to use the return. So all this is going to do is going to basically calculate those two values that's given to the program later on, and it's going to return the value. And we just close that, and then we'll do a big close at the end. Imran, you got that? Yes? So we'll do the close down here.
And we finish with a semicolon?
No, this for that method.
No, after return h.
At the end we'll do that. Every time we open a
After
brace,
return h dot, it should need a semicolon.
Which h?
The
Oh,
return,
this is
yeah.
return, yeah, that's what you're correct. I did that on purpose. Just to see if anyone's going to talk. That's pretty much an object. Well, not an object, it's a template of an object, because it's a class. Class are templates of objects. So it's basically, if you want to simplify another way, it's like a blueprint. So every time we want to create a table, we want exactly that dimensions, everything, and every time we say, right, okay, let's start manufacturing tables, table 1, table 2, table 3, and we just multiply. So I think Farzan has a good example in your pizza example. What was it?
Well, if you want to have a party, you can like just get all the ingredients and make a pizza in your, just inside your house, and just do everything together, and having a pizza at the end of the party, just people that can have that pizza. But the problem with that is so much thing is happening inside your house. You want to organize a party, and you don't want to someone is just playing around with the ingredient and making a pizza. So what you can do, you can ask someone else, or a shop or pizza delivery, do these things for you and deliver the pizza. The result is exactly the same thing, but you're not doing all those process. You're not dealing with the ingredients, with the first material or everything inside the house. So so you can
So
just
the
technically
pizza shop will have a
outsource.
template basically for the pizza.
Yeah.
To say, right, so basically this size, the toppings will be this. They've got their own formula. same thing in class employee. Every employee would have an employee number, employee name, and every employee would get paid a salary, so they would get salary. Who wants to
One of your main methods, if you want to call the get salary.
create the object?
Yeah, creating.
That's what I'm going to move on to next. But before I do that, I just wanted to give you an idea as well on here. This is the same in, let's put Java, C++. I'll tell you a slight difference, C# in a minute, and not Objective-C. So if you write this code, it should work in all these languages, except in C++. Who's done C++? Any C++ here? Done a little bit of C++? The difference is, you write this code and you put a semicolon at the end. If you put a semicolon down here, this code now will execute. That will create an object in C++ as well. That's just a minor difference, and you already know C++. So if you know Java, all of a sudden now you know C++. C# and Java are very, very close. Very, very close. I'm going to give you the minor differences in a minute as well. Right. For Objective-C, I'm going to try to do it on the board here. It's completely different. What I'm going to do, just to clarify, is I'm going to cover the object-oriented programming as much as I can within the time, next 15 minutes. And I'm just going to give you an idea of the different languages. So here, for example, we've done C++, C# as well, C#. And we did Java. In Objective-C, so if you want to get into iPhone programming and stuff, you need to learn Objective-C. The way you do an object, you put interface. All of a sudden it's a completely different language. You start with that asterisk interface, and then the name of the object, which is employee. Okay? And then you say the properties, for example, you said int number, and we said string employee, and then what you do. Is that correct?
Yeah.
Right, okay, what's the next thing? You do the function after that. So you start now defining all the